All right, Shorty, here we go. Solving inequalities, day two. We're going to talk about a couple of things before we move into solving. All right, real quick. Um, you did a really good job on the last homework assignment. You got pretty much 100%. So it seems like you understand the inequalities. Now, let's translate the verbal expression to the inequality. So x is greater than negative 14. When we see that x is greater than, right, negative 14. Remember, the alligator's always eating the bigger number. The next one, x is less than. So x, the less than or equal to symbol, all right, is here. All right, and it's less than or equal to 2. So being able to take these words and translate them into inequalities is very important. Okay. So now, the other day we talked about these inequalities and what they mean. And with this, the first thing we're going to talk about is the solution to an inequality. The solution to an inequality is the value of the variable that makes the inequality true. So when I have something like x is greater than 5, right? I can pick numbers to plug in for x. And the solutions, right, would be the numbers that make it a true statement. So if I put x equals 3 in there, is 3 greater than 5? No. Therefore, that's not a solution. But if I say x is equal to 8, is 8 greater than 5? Yes. Therefore, 8 is a solution to the inequality. Now, when we have other coefficients and variables and all that in this, right, we have to find the value of the variable that makes the equation or the inequality true. Now, solving inequalities is no different than solving an equation, right? The only difference is when you multiply or divide both sides by a negative, you must flip the inequality sign. For example, is 3 greater than 1? Yes, it is, right? But if I take that and I multiply both sides by negative 2, I end up with negative 6 greater than negative 2. Does that remain a true statement? No, it doesn't, right? What I have to do to make it a true statement is remember you have negative 6 and negative 2. Negative 2 is bigger, right? So anytime you multiply both sides by a negative, you have to remember to flip the inequality sign. So solve and graph the following inequalities, right? So to solve this, I know to get rid of the 5. I'm going to add it to both sides. And I bring down the x is greater than 6 plus 5 is 11. I would go to 11 on the number line. It's going to be an open circle, and I'm going to shade to the right. Okay. Next one, x plus 9 is greater than or equal to 3. To get rid of the 9, I'm going to go ahead and subtract it. X is greater than or equal to 3 minus 9 is negative 6. So right away I go to negative 6. I'm going to have a closed dot, and I'm going to shade to the right again. Okay. So next one, solve and graph this inequality. To get rid of the 5, I'm going to go ahead and subtract it. So x becomes less than negative 3 minus 5 is negative 8. Remember, when you're solving these equations, to keep track of the signs correctly. So I'd go to negative 8. It's going to be an open dot. Since it's less than, I'm going to shade to the left. Now this one gets a little tricky, right? To solve this one, I'm going to go ahead and add the 10 to both sides. Now, when I add the 10, technically I get 4 is greater than x. But here's the thing, it's hard to graph from here. Now, if I graph from here, I would go open circle, but I always want to read it from the variable to the number. So x is less than 4, so we would shade to the left. Now, what I like to do is rewrite this inequality with x on the left, 4 on the right. And if I look, the alligator right now is eating 4. So I would keep it eating 4 and then just go ahead and graph x is less than 4. Okay. Now, 3 is linked to x in this problem by multiplication. How do we get rid of undo multiplication? Using division. So I'm going to go ahead, divide by 3, and I get x is less than 4. So open dot, shade to the left. But the next one, if I look, how do I get rid of the negative 4? I'm going to have to divide by the negative 4. And when I divide by negative 4, since I am dividing by a negative, I must flip this inequality sign. So it's going to go from greater than or equal to less than or equal to negative 4. So now I can go to negative 4, close dot, shade to the left. So again, notice, what did I divide by to get x by itself? I divided by negative 4. The next example, what am I going to divide by to get x by itself here? I'm going to divide by 6. So x and then negative 5. Do I have to flip the inequality sign? What did I divide by here? I divided by a positive. Therefore, I do not flip the inequality sign. So now I can go open circle, shade to the right. I know I can test if I forget what I have to do, I can test because all of the solutions to this problem, all of the solutions to an inequality are the numbers that lie in the shaded region, such as if I take 0, 6 times 0, is that greater than negative 30? Yes. If I say 10, is 10 in that shaded region? Yeah, because this technically goes forever and ever to the right. So is 6 times 10 greater than negative 30? Absolutely. So any number greater than negative 5 will be a solution to the inequality. Here, what am I dividing by to get rid of the 2? Now, when I write this, x, negative 8 divided by 2 is negative 4. I divide it by a positive. I don't flip the inequality sign. But remember, if I have this, if I divide by that, I get negative 4 is less than x. But I want to rewrite this so the alligator is eating the x. So I'd go to negative 4, shade to the right. Next one. If I look at x and 2, this is x divided by 2. How do I undo division? I multiply. When I multiply this side by 2, those cancel out. I get x. Multiply this side by 2, and I get is less than or equal to negative 6. So I'd go close dot on negative 6, shade to the left. Couple more examples here. Here, x and negative 4 are linked by division. How do I get rid of it then? I'm going to go ahead and multiply both sides by negative 4. Now remember, I multiply both sides by negative 4. Therefore, I have to flip the inequality sign. And that would give me x is greater than 8. So I'd go to 8, open dot, shade to the right. Three-fifths is linked to x by multiplication. Now, with these problems, I'd use 2 steps. I get rid of the denominator first. I'm going to multiply both sides by 5. These 5's cancel out. I'm going to bring the 3x down. So 3x is greater than negative 30. How do I get rid of this 3 now? I divide. And x is greater than negative 10. Remember, I divided by a positive number, therefore I do not flip the inequality sign. And the last example here. I see I have negative 2/5. So what I would do is multiply both sides by 5. But what do I have left here? I have negative 2x. Oh, let's go ahead and change this to greater than or equal to. Sorry. Negative 2x is greater than or equal to, multiply this side by 5, and you would get 20. But now when I divide by negative 2, I'm going to get x and then negative 10. Because I divided by a negative, I'm going to have to flip this inequality sign. So it has to become less than or equal to. So now, close dot on negative 10, shade to the left. Okay, so tomorrow we'll step it up with the inequalities a little bit, but for now, right, this should get you going on this next lesson. All right, enjoy today and see you at practice.